I'll get started now and say people can join us as we go along. So yeah, thanks everyone for joining this exciting session on demystifying the role of machine learning and artificial intelligence in the decarbonisation of buildings and the launch of our new Predict tool, which is super exciting. In terms of an agenda, so this is going to be about 45 minutes, this session. I'm going to give a quick overview of Optimize AI and the journey that we've been on to get to this point. Then I'll be handing over to Pooja Balachandra from Carbon 13, and you'll see how Carbon 13 have been an important element, if you like, of our journey. And she'll be talking about how technology in the built environment is combating the climate crisis, and about products and tools and companies such as ours and why they're so important. Then I'll show the Predict tool and tell you how to all get started in using it. Then I've got a session from Professor Yassine Rezgi, the Optimize, my co-founder, on ML and AI in how we utilize it and how it can be utilized in decarbonising the real estate. And then there's questions and answers. Please feel free to put your questions throughout the session into the Q&A section in the Zoom in the bottom. I think it's on the bottom. You can see it. And Joe here, who's my commercial lead, will be collating them, and we'll do a Q&A session hopefully for the last 10 minutes. Also on the call, finally, is Anna, the marketing lead for Optimize. So yeah, let's without further ado, who am I? I think lots of people on the call know who I am. I'm Nick Tune, and I'm the co-founder with Professor Rezgi of Optimize AI, and I'm also a commissioner for the National Infrastructure Commission in Wales. And I was previously in Atkins and done lots of other exciting stuff. Our mission, if you like, with Optimize is to save over 10 megatons of carbon from data poor buildings. And I'll come onto that in a lot bit more detail through the presentation. But our feeling, if you like, our thesis or hypothesis is 99% of the buildings out there are not being looked at in terms of decarbonisation and energy reduction. And if we're to reach our keeping global temperatures under 1.5 or even 2 degrees, we have to be addressing the built environment and all these buildings that currently aren't being looked at. So that's our vision, our mission to actually do that. So a bit about our journey, because it's a really interesting journey in terms of how we got to this point as a startup. It started donkey's years ago now, 2007, which is a long time ago, when I was at I set up the Building Research Establishment in Wales, and then set up a research centre in the School of Engineering in Cardiff University, and appointed Professor Rezgi as the chair. And he introduced me for the first time to BIM, Building Information Modelling. I'd never heard of it before. It was before there was a BIM mandate. It was very kind of nascent in its usage. And we started then doing bids on how can you use BIM to manage energy in buildings. And we won many, many research projects from Framework 7, Horizon 20, Innovate UK, on the use of digital technologies to make a more sustainable built environment. After I left BRE, the guys at Cardiff University carried on working, obviously, and they ended up finding a patent on the use of semantics to manage buildings more effectively. And the semantics, I'll talk a bit more later, but in effect, it gives context to and better understanding to the building to be able to make more informed decisions. And then going to the beginning of last year, we thought we can't do any more research projects because we've done so many of them. We actually need to spin this thing out as a real business. So that's when I started the journey. And that's when I met Pooja, March last year. And we went on the Carbon 13 venture launchpad journey, which was excellent in getting us set up and ready to go as a business. And they then invested in us, which was fab. That triggered loads of other investment. So on the back of that, we had angel investors, Development Bank of Wales, and then we won research funding from Department of Energy, Net Zero, Welsh Government, and Innovate UK, and had massive support from the Connected Places Catapult. So then to this year, we've been working on taking it from a TRL 7 which is where it was at when we picked it up. In other words, it's a working product, but not maybe commercially active, if that makes sense, and making it to TRL9. And we've been doing that again with the help of the Catapult has been brilliant. And we've been working with Bristol Temple Meads. We've been doing projects on ScotRail. We've done projects on Luton Airport, University of Wales, Trinity St David, Exchange Key, and lots of others. It was great. Then in March this year, we won the Wales Tech Startup of the year. And now here we are today with the launch of our main product now, SaaS product, which is Predict. I just covered, I think, those. So in terms of the awards, in terms of some of the funding, and in terms of some of the clients that we're busy working with. So that's by way of intro. So as I said, Pooja was very instrumental in our journey and helping us get set up as a business. So I'll hand over to Pooja to talk about, how the likes of ourselves and how to get more entrepreneurship almost in this ecosystem going forward. So over to you, Pooja.
Amazing. Thank you. Thanks, Nick. I'm going to just oh, perfect. I'm going to close this and share my screen. There we go. You all are seeing my deck, right? Perfect. All right, let me just get the presentation set up. And, oh, there we go. Slideshow, here we go. So hi, everyone. I'm Pooja. I'm the Director of Venture at Carbon 13. And at Carbon 13, we build and back ventures addressing Earth's critical life support systems. So let me just go back one slide. So of which Optimize AI was one of them. And one of our big kind of focuses, we really focus across many different verticals. But one of our big focuses is around the built environment. And one of the things I'll talk about, one of the reasons we think it's so important is because as our population urbanizes, we're looking at, another 2.5 billion people living in cities by 2050. Obviously, the built environment is only going to become a bigger contributor to carbon emissions, but also we think there's a huge opportunity around actually it being a platform for a lot of the innovations that we're seeing even across other sectors. So for example, things like agriculture, things like industry that are going to start to be urbanized as well. And we see the built environment as a massive lever in our in our fight against climate change. So specifically, I wanted to talk to you about kind of 5 different trends and opportunities for climate tech in the built environment, starting with 4, but I have a fifth that's a bit of a segue into our next bit of the presentation. So the first is around moving beyond recommendations to actual actions. The other is looking up and downstream to remove barriers to deployment of technologies that we already have. The other is around adaptation as an opportunity. And finally, like I referred to before, urbanization as kind of a platform for innovation. So let's start with moving beyond recommendations to action. So the problem that we are seeing, and I think as Nick alluded to at Carbon 13, we're seeing a lot of ventures in this space, particularly in the early stage. So I think we have a pretty good kind of finger on the pulse of where innovation is really happening. And I think so far, what we've seen is that innovation has been concentrated on making reporting and recommendations easier and more accurate. But the challenge is that there's a gap that remains between actually, telling, let's say, a building owner or a real estate investor or something along these lines what to do versus what actually gets implemented and when the actual decarbonization and carbon mitigation is realized. And we think there are some really big opportunities around closing this gap. So one is around using AI to optimize energy performance and actually make better recommendations that are more actionable. Optimize has already been doing that work excitingly, and that's why they're part of our portfolio as well. The other is around deploying established technology more effectively. So things like heat pumps, solar, electrified HVAC systems, all of these are technologies that already exist, but there are challenges to having them deployed, which I'll get to in my next slide. And the final one is around really development and validation of new technology. So things like carbon negative building materials. We have quite a few companies in our portfolio as well that are working along these lines. And we see a big opportunity around actually kind of changing the economics involved so that more technologies can be deployed in the built environment as well. And we can, again, cross that gap between recommendations and reporting to actual implementation. The next sort of trend that we're seeing is really companies that are looking up and downstream to remove barriers to deployment. So actually, Optimize might even be one of these as well. And a big challenge is around a lack of data, so that if any of these interventions actually need to be deployed, you need the data to understand, okay, when should they be deployed, with what specifications should they be deployed, all of these sort of things. A lot of the time that data is missing, so the data layer is quite important. And we're seeing that like the barriers like this, like the lack of data, like complicated and complex user journeys. So for example, a really classic example is around heat pumps. If you're trying to get a heat pump, in theory, it's a good choice for most people. But the challenge is that the user journey from doing the initial research to actually getting someone to come to your home and spec it out, to then the financing involved to actually to actually afford a heat pump and implement and get it installed in your home, to then actually maintaining it and continuing to and using it properly over its lifetime. I think all of that is so much more complicated than expected, that it's really slowed down the deployment of an otherwise kind of no-brainer technology. Another one that's obvious is that we see often is around lack of financing options. So, for example, even these technologies that do exist that we know work, that are relatively affordable, it still comes with a CapEx cost, and often the financing options available aren't adequate. The last one is really kind of an unclear, uneconomical ROI. So, for example, technologies that feel like a no-brainer, but then actually when you dig in a little deeper, you realize that there's a reason they're not being deployed, and it's because people have done the ROI calculation and determined it's not worth it. Or they're being fed information that makes it difficult for them to actually do that calculation. And so along all of these lines, we're seeing that there are these barriers to established technology that seems like kind of a no-brainer, still struggling to get deployed at scale in the built environment. And we think that there are opportunities for kind of smoothing that user journey and addressing all of these barriers along the road to deployment. The next one is around adaptation as an opportunity. So as the climate warms, we know that natural disasters will become more frequent. We know that there are new opportunities for the built environment to actually adapt. And some of the ones that we're seeing are around low and zero carbon cooling, retrofitting for wildfire or flood prevention, risk analysis and insurance products for the built environment. So there's a whole kind of area of opportunity around there as well. And then finally, around, kind of like I alluded to at the beginning, the built environment really is a platform for all these other innovations. So as the population moves to urban centers, we're seeing that food production will move there as well. Industry will move there as well. And so we think the built environment can actually be a platform for decarbonizing these other verticals beyond strictly buildings, and also being a vehicle for carbon capture, storage, and removal. So for example, one of our portfolio companies, Neom, they do decentralized microreactors that are producing green ammonia. That's an example of industry starting to become more decentralized. The other is around food production, either via biotech. We've had companies that have come through the venture launchpad that are working on growing food in bioreactors, to all the way to kind of integrated agriculture. So there have been companies that are working on green roofs, or there are people that are working on a paint that sequesters carbon for the outside of buildings. I mean, all of these opportunities that are using the built environment as kind of a platform for all of these other innovations as well. But like I alluded to earlier, all of this requires that data be that there be a data layer that enables all of this to happen. So for example, if you're moving from recommendations to action, you need to be able to give the right recommendations based on a certain data, based on data available. You also, if you're trying to close those barriers to entry, barriers to deployment rather, things like, for example, financing, require data around the efficacy of the interventions that you're doing, like accurate data around the revenue that might be generated from this, or the savings that might be generated that you can then draw from to get a payback and to calculate ROIs more effectively. Around adaptation, for example, things like risk analysis and risk quantification. The data is incredibly important around those things. And then once you actually deploy interventions, what's the efficacy of them? And then, of course, around the built environment as a platform, all of these kind of solutions that would be built on top of the built environment will be having that same kind of upstream and downstream calculation around whether they're worth deploying. And all of that requires data. So with that, I will hand it back to Nick to take us forward.
Fabulous. Thank you, Pooja. And don't forget, guys, to put questions in the Q&A box for later on. So hopefully, Pooja, you can answer some questions at the end of the session. So as a great segue, let me just go back to my screen. Again, hopefully you can see my screen now. So the problem that we're addressing, which Pooja just alluded to, is the lack of data. So 90% of buildings don't have a building management system. 90% of building management systems are really ineffectual. When we started this journey, we thought, yeah, it'd be great. We'll go and start rolling this out, making digital twins on loads of buildings. And then you realize that the people who have these buildings just don't have access to the data. So what are you going to, what can you do then? I would say, 1% of the buildings out there, people are putting a lot of effort in and you've got state-of-the-art BMSs and, if you like, moving towards a smart building, but we're a long way for that 99%. So this is how we do it. What we do is we take whatever data is available, ideally a smart meter, but we also take in the BMS data, IoT data, other data sources. And then from that, we create a semantic digital twin, which utilizes machine learning and the use of ontologies, which allows us to provide context of the building and understand the data better so that we can understand the cause and effect relationship of how the building's working and how it's working with the human. That allows us to have a greater insight from the data that's available, which allows us to do much more with that data. The methodology really looks like this. This explains it quite nicely. I often say this is three legs of a stool. You have you have at the bottom left, for instance, an energy simulation model, the likes that you'd use to make an energy performance certificate, but that is just purely theoretical. It's not couched in the actual reality of your building whatsoever. So then we connect that with the actual data. So from the meter, for instance, say there's a smart meter. So now we can actually make sure and recalibrate the model to make sure it's actually based on the real data from the building. But then when we're going one step further than that again, is what we've done is we've collected as many data sources from buildings as possible, where we've got literally millions of data sets, and we've trained models, AI, ML models across that data set and then basically the view, if you like, between the actual data, the surrogate theoretical model and the big data model is what allows us to get that extra insight. And what we find is, as I said, if you look to the right-hand side of this diagram, with a high level of data maturity and great insight, we kind of thought that lots of buildings would be like this. And the reality is we're not on the right-hand side, we're on the left-hand side where, there is very limited data maturity and limited insights. And most buildings just have a meter and they might have a theoretical, again, EPC. So our mission is to get people on that journey up the chain, if you like, up the arrow. So let's get going and work on what you've already got. Then let's start adding to it. And then we can start adding more information about your building. So in other words, what LED lighting or not do you have? What's your U value? Changing the parameters to increase the accuracy. And then start adding other data sets. So we can then start adding sub-metering and then start adding IoT, the BMS. And then we're moving towards the right-hand side where we actually have, if you like, a full digital twin, what you might call a smart building. Now, our Predict tool, which I'm going to show now, sits, if you like, at that entry level point. So we want something that people can just get started. It's not perfect. It's just literally, at the moment, most people just only have a data from their meter they don't even look at, and an EPC that's usually wrong. How can we actually get people started and get them some really great information and move them up that journey towards Optimize, which is the full digital twin product? So I'll now give a demo of the Predict tool. The Predict tool, as I said, is meant as an entry-level product to get started if you just have a meter. And it allows us to do really quickly many, many buildings really fast, way faster than going, if you like, and to audit millions or hundreds of buildings. You can literally do this for your hundreds of buildings, have the helicopter view before deciding which ones to focus your real effort and go down deep to investigate. So I should now show Predict. So I will put in a location into the tool. So once you log in, you'll see this view. And this is now gone to Ebbw Vale, where we've been doing one of our projects. And I'm just picking this here, this learning campus. Then I'm going and picking the energy supplier to the learning campus. I don't know which exactly what it is, so I'm kind of guessed. And then I then connect my meter. Now, I'm not sure what the meter is for this, right? So you could bear with me. This is just a demo. But if you have your MPAN number, you enter your MPAN. Now, if it's in the system, which most are, then what you then do is you then tick a box saying you agree as to access your meter. Then we can then start getting your half-hourly meter data. So I'll just pretend for now, I'll just say this is it. I'll say how much energy is being used in this building. Again, I don't know, I'm making this up. And I'm saying, this is what we're paying for, this is what I'm paying as my unit rate in energy. Then we've now found your building, and we've actually now found you've got an EPC. And by pressing that now, I'm now uploading your EPC. So now I've got your meter, half hourly, and I've got your EPC. And now you're going to give some more information about the building. How many floors? What's the main heating type? How's it ventilated? What was the year of construction? What's the type of building? So if I go to, hopefully I can find this now. I'll just go other education. And then what's in the individual building made up of, the types of rooms and spaces. And what we're doing is we're using this information now. We're using them, as I explained, we're using the EPC, the meter, the info you've added, and we're using the mapping so we know the size of the building, the height of the building, the makeup to trigger the two models I mentioned earlier, to trigger the simulation model, just the energy simulation model, and the big data simulation model. So that is now going to do, once I click finish, that will then do that triangulation that I showed earlier. So let's just say I clicked it, and now I'll just show then what the output now looks like. So this is now the output, and now I can see the actual consumption here for the building. I can see how much carbon is being emitted from the building, and I can see how much is being spent because obviously you've told us your unit rate. And now I can start to see how, and now I can disaggregate and say, from the modeling, this is how we believe the cost is made up, or this is how the carbon is made up. And I can see here now the consumption. So you can now, basically, this is now connecting to your meter, showing this nice interface of your meter, and also the model then giving a disaggregation so you can see where it's being spent. Now, also, the other thing as well you can see is this won't be relevant for a big learning campus like this, but for smallish businesses, we're, for the first time ever, this is really important, showing you all the tariffs that's available to you so that you can switch, and showing you, based on your historic usage and your predicted usage, which is the best tariff for you. Now, you cannot find this anywhere in Britain at the moment. The only way you can change tariffs is via a broker, and that system is reminds me of insurance from the 1980s. Those of us who are old enough to remember that, I can't believe the system still works like this. So working with our friends at Future Energy Associates, we've pulled this together so that you now can see, right, this is a better tariff for me. If you want to go and get the tariff yourself, great. If you want to go through your broker, not a problem. We're not acting as that. We're switching service, but we're just giving you the information so you always know, and this is updated daily, which is the best tariff for you. So then I go to diagnose, and then I can see how my building is performing against similar buildings to me. So this is an EPC of an F, could get to at least to a D. It should get higher than that because it's a brand new building. And then what the implications of it not being at the higher level of EPC. And then I can now also click here and diagnose. So this is really cool. So this shows my actual consumption. And this then gives the machine learning now a prediction model of what your consumption will be as you currently are operating. So now I can see, I can compare to similar buildings, I can see how I'm using, and now I can predict into the future what I will be using. And then if you just click here, so our AI is generating this, well, our machine learning and AI. This shows you, I won't go into this now, the methodologies that we use, the AI ML methodologies, which Yassine will talk a little bit more about in a moment. Sorry, I just got to flick back to the screen. Right, so back to the main screen. Then we go to potential. This is what you could easily get to without a huge level of investment. And then we view the improvement plan. So now this is the really cool bit where you can see if you do these measures from our many, many energies, we've got hundreds of saving scenarios. These measures, based on the calculation and the measures that we're suggesting, can make this level of saving in terms of carbon, in terms of pounds, in terms of energy. And on an upgraded version, we've also got a return on investment calculator so that you can literally put in your ROI. You can say how much the capital cost will be, and it will do a return on investment calculation. And ScotRail, for instance, are using this to plan the decarbonisation of all their stations. So they can literally go through, do all the different things, aggregate, and start planning a costed plan as their route of decarbonisation. If I click on one of these, what you should now see is the expected predicted consumption going forward, and what will be the predicted consumption if you implement that scenario. So you can see what the benefit will make. And I can toggle different solutions on and off. And so I can, obviously put them on top of each other. Some can't work, obviously, with others. And then this is, again, really cool functionality. I click see how to provide more detail. Now, we've made our own large language model that is basically going over sources that we have checked that we are happy with, because as lots of you will know, your ChatGPTs of the world hallucinate and don't always give you the right information. We've checked it. We're making sure that the sources are reputable sources, if you like, and will then give you recommendations, specific recommendations then on the implementation of these measures. So you can see around the implementation roadmap, the current performance assessments within the building, the pathways. So lots of information. And then we're then going to add the ability to then query this in an LLM utilizing, I can't remember which platform, like a ChatGPT. So you can query this even deeper, but obviously that comes with a health warning that you're then sipping out of our system. But what we want to do is we always want to give you that virtual consultant. So we're not only showing you the performance, we're then telling you, what's wrong with your building. We're then telling you how to improve it. And then we're actually practically, what can you do? And allowing you to go right the way through on that journey to improve. And then just one thing I can see if I can quickly show you, if I go to some other examples, like ScotRail here, I can see lots of different stuff, their stations, and they're using this to be able to see, how their portfolio is operating. And we're going to be soon showing them on like a map view of Scotland, all their different stations, red, amber, green, them which are going well, which are going bad, which need improving. So a way for them to monitor and plan their route to net zero across their whole estate. Now, so that's predict. I'll then go back to the presentation. And this is going to be now available to everybody today for free. And let me just explain what we plan. Once you go on and register, and you see here, for instance, let me pick a good one like Inverness Station. Oop, not that one. Perth Station will do. Everyone will be able to see this as a tool, and then you can see the tariffs. So this is free. So it's going to be free. This is free at the moment in perpetuity. We're then making the whole rest of this tool free for the first 25 companies that use it, providing you give us loads of great feedback and everything else going forward. So, you get on as of 12 o'clock or whenever today, you'll be able to register and get using this, and then register for the whole thing. And all you need is your MPAN, which is your smart ID, meter ID, to get started. That's all. Fill in the form exactly as I showed you. So there we are. Now then, the final bit of the talk, which was why a lot of people of you come here. Let me go to my slideshow again. is what tech do we use to do all of this? I've alluded to it. So Professor Rezgi now will give a presentation about 8 minutes on the actual tech. So this is get techie, guys. Stay with it because hopefully you'll learn something. I certainly will.
Hello everyone, this is Yassin Rezgi. I'm going in this short video to give you an optimized AI perspective on the application of machine learning and artificial intelligence to decarbonize our buildings. Now, the first thing to note is that we have a massive non-domestic stock of buildings, which is estimated at 2.13 million. The two-thirds of this stock was built before 1970, while a quarter was built before 1900, at times where the energy regulatory landscape was far less stringent than is today. We categorize our building stock into 3 types of buildings. So we have first buildings that do not have a building management system or BMS. We have buildings that are equipped with a BMS, but the BMS tends to be outdated or inefficient. And we have new buildings that are equipped with a state-of-the-art BMS. Now, the way the industry, including consultants, address the energy efficiency agenda involves, in many cases, reliance on building physics models. Now, these building physics models are highly reliable and robust. However, the sole reliance on these models can be a real challenge and not practical, given the massive building stock that needs decarbonizing. I will now introduce and summarize the optimized AI approach to machine learning and AI for energy efficiency. We operate at either building level, or we can also operate at a district level, or even go wider and operate at a city or national scale. Our approach relies on the use of semantics based on a patented method that we use. The way we approach the complexity of a building is by dividing this complexity into discrete scenarios with the understanding that addressing each of these scenarios will collectively address the holistic complexity of the building. So the way we proceed is by first translating a scenario into a semantic representation. Once we develop that semantic representation, we start constructing one or several machine learning models, which are trained, the best selected, and then we choose an optimization algorithm based on our libraries of reusable and adaptable machine learning algorithms and optimization algorithms. When the algorithm is selected, then the optimization points are defined and the optimization output then feed into the controls of the building. It's important to note that we optimize our models in 2 stages. First, we fine-tune parameters within the machine learning process to enhance performance. Then, after the model is deployed, we use actuators to adjust features, ensuring the outputs closely match real-world conditions. Now, our models are far from being static. Our models are dynamic and tend to be calibrated on a regular basis. Model calibration is very important. We achieve this through our proprietary methods. Specifically, we continuously monitor the mean error between our model's predictions and actual data. If this error exceeds a threshold, we proactively retrain our models to incorporate new data patterns or apply bias corrections by adjusting the output. Now, this dynamic calibration process ensures that our models remain accurate, reliable, and reflective of real-world condition. So it's important to note again that we use retraining of our methods when data patterns change significantly within the building, or while bias correction is applied to fix minor systematic errors. Now, I'll try on this slide to explain or give an overview or examples of the type of algorithms that we use across the process I've just shown now. So, for example, to improve the interaction between agents, what we term as agents can be either human agents or software agents. So a human agent can be the occupant in the building, can be a facility manager, or simply an expert. So we tend to rely on generative AI. We use large language models to improve the interaction between occupants or agents with our system, and also to assist in the translation of a natural language query or scenario description into a scenario that is grounded in the semantics of our domain or ontologies. We also then try to simplify the complexity of a model by using principal component analysis, PCA. The use of PCA is quite useful to reduce the dimensionality of a model or a problem into the key governing variables. So PCA is quite useful in that perspective. There are other methods, but this is just one example, of a method that we use. In terms of machine learning models, we have our own library of reusable and adaptable machine learning algorithms. So we sometimes use supervised learning, where we rely on artificial neural network or random forest, as well as other algorithms to resolve a given problem or scenario. In terms of optimization, again, we can deal with single or multi-objective optimization. We can rely on a wide range of algorithms stored in our library of optimization algorithms. An example of the algorithms we use involves the use of genetic algorithms or neural networks, or a hybrid method which involves both methods in some instances. In terms of calibration, we rely on our own methods, so we have our own proprietary. Hello everyone, this is how to benchmark energy consumption against similar buildings to determine the necessary interventions to enhance energy efficiency and the EPC rating of a building, to continuously optimize energy consumption in a building while reducing carbon emissions. And we also use machine learning and AI to promote the participation of buildings in demand flexibility management. In this last slide, I will benchmark the traditional physics-based approach versus AI-driven approach to energy modeling. For that, I will use a number of KPIs, which are accuracy, setup time, adaptability, insight, scope, and scalability. Starting with accuracy, the AI-based approach provides real-world and adaptive insights into energy modeling, whereas the traditional approach, physics-based approach, tends to be theoretical and input-dependent. From a setup time, the AI-based approach tends to be faster with all the data infrastructures involved, whereas a traditional approach tends to be long and based on detailed data requirements. From an adaptability perspective, the AI-based approach tends to be dynamic and self-learning, whereas the physics-based approach tends to be astatic and requires continuous manual updates. From an insights perspective, the AI-based approach provides real-time, actionable recommendations, whereas the physics-based model tends to be theoretical and based on theoretical, again, performance metrics. From a scope perspective, the AI-based approach tends to focus on operational optimization, so the operational phase of the building life cycle, whereas the physics-based model are best suited during the design phase of a building. Finally, from a scalability perspective, the AI models tend to be highly scalable across buildings, whereas the traditional approach tends to be fairly limited in terms of scalability. So this is in a very...
Sorry, apologies. Voilà. Hopefully we covered the most the presentation there. So yeah, sorry, my cack-handedness managed to cut Yassine off a little early there. But as you could see now, hopefully you could understand how the use of machine learning and AI can and is being used to understand the data from buildings more effectively and to allow better insight into to the management and the decarbonisation and the energy minimization of assets. So in terms of our product, I went through Predict. Predict's free. I'll talk about that, get started today. And then Optimize, as I showed earlier, is our much more detailed, full digital twin that goes right the way down to room, a system level, much more granular, where we're taking in the BMS, where we can literally override the BMS, as in make a virtual BMS. We take in the IoT. In Bristol Temple Meads, we take in ticketing data, we take in train timetable data. So if you like the entry point to Predict, get started with a meter. We then grow, bring in more data as is needed, and then go up the way to the full digital twin, where we're connecting with all the different data, and we're data agnostic. So we're in effect pulling in all the different data sources that you have out there to provide the maximum level of insight. So that's it. We've only got a few more minutes for questions, so we've gone over slightly. I'll go over the time by a couple of minutes. But most important, guys, get your phones out, take a photo, and sign up now for Predict. You just need an MPAN to get started. And then we're going to give the first 25 organizations free access to the whole lot for your feedback for 3 months. And then before April next year, there's just a one-time fee setup of £800 a building. So really, really cheap. And if you've got more than 10, then we'll make it, we'll have a chat, make it even cheaper. And then after that, then providing after that year, then there'll be an ongoing SaaS fee. But again, we're keeping that low entry point, so you can put in your whole estate, if you like, to get started and moving up that journey. So yeah, register. You can sign up. Fingers crossed it's working. Sign up and register now. So that's it. 2 minutes left, Joe. If there are any critical questions, then more than happy to Pooja and I or whatever to answer them.
Yeah. Well, there's a couple of questions. Just to let everyone know, I've put a sign up link in the chat. Hopefully that works for everyone. But yeah, we have had a couple of questions. A couple of people asked, obviously, if we're doing a video and replay. And yes, we will be emailing out an email after this to everybody with the video. Somebody's asked if we're providing the actual presentation document as well, Nick. I'm not sure if that's something you want to do or not.
Yeah.
But yeah,
okay,
great.
Yeah.
So then we will. Pre-temp, so there you go. So Jamie Hindle asked, presume you will start with a commercial offering before any domestic offering?
Yes, that is where we started. Absolutely. But as we were going down this journey, so we never saw Optimize, which is the full detailed digital twin for housing. And I still don't see it for housing. But the entry, if you like, and the ability to look across whole estates really quickly, when I've been now speaking to housing associations, and they really want it because they need their routes to net zero. They call them the pathways, and Welsh Government have mandated it for the housing associations. So we can use Predict to do that. And they're deciding what to do in these pathways purely based on EPCs. So purely based on theoretical models that, as Yassine said, have got no thing in reality. So there's a massive opportunity we see for housing associations, and we will be releasing a product in the spring, I'd say, for HAs.
Brilliant. So Raj asked this. He asked this quite early on. Raj Basra. He asked quite early on. So hopefully the questions have been answered. This question has been answered already by your presentation, Nick. But just in case you've got anything to add, Raj asked, could you provide examples of how your AI/ML machine learning algo is providing value to the end customer?
Well, hopefully that was well and truly answered by Yassine's presentation. Because, I think there's no point me going over that again, because that is exactly the end bit that Yassine presented. So hopefully, Raj, you've got the answer for that. But I'm sure you can have a much more detailed conversation with some of our academics if you wish, no problem. But I'm not the expert, so I think we've covered it.
Yeah, I think you showed how the system can generate suggestions and all sorts.
Well, it's all about using that technology to actually get better insights to save energy and carbon emissions.
Yeah, definitely. Great. We've got a few more actually. Nick, Johan's asked if he could create a blog. He'd be happy to create a blog or case study with some of the data. And it's been an
Great.
excellent presentation. Thank you, Johan. Nicholas Darling said, if you're estimating energy reductions or revised costs based on various options, what warranty is provided for these recommendations?
Oof, God, that's a question. Well, at the moment, they are coming as recommendations, right? So the same as, this is a really interesting point, the same as a human, right? So the human, I often have this a lot with people when they look at machines, because they think everything has to be 100% accurate, and we're trying to make it as accurate as possible. And something we're going to show actually is the accuracy of our models. So it's 78% or 90%, and you can then make the decision based on whether you wish to enact it or not, right? But at the moment, what's the current state of the art? The current state of the art is if you have a building you want to improve, you do an audit, and then you might do an energy simulation, and then from that, then you determine what to do, and then you then go and survey, and then you go and do it. Well, again, that's all theoretical, and that's just made up one person's brain, right? So again, to cover that, you have professional indemnity insurance on the individual. What we're doing is the consultant can utilize their own inherent knowledge, but now they've got more data to make that decision. So if you like, it's helping there to sit alongside. AI is not going to take your job. Someone using AI is going to take your job. This is, if you like, to help work with a consultant to help them to give better insight to how to manage the building. So I wouldn't say that it would be, this is a 100% guarantee. Everything we suggest is 100% right. We'll tell you as part of our journey the percentage accuracy, and you have to decide whether you enact that or you allow the AI to run it for you, which it can do in Optimize. And I think we're almost up for time, Jo.
Great stuff. Yeah, the only last question was Cecilia Skarupa saying, what is PM as in 50 PM, £50 PM? It's per month.
Oh, right.
Cecilia. So yeah, it's a monthly SaaS fee.
But that won't kick in if you register now. So that will only kick in after the year. So as I'm saying, if you've got more than 10 buildings, we can have a chat and there'll be a reduction, obviously for bulk. So, £800 for a building to get, well, actually nothing if you do it now, but then £800 is a ridiculously low amount to get all that insight. Thank you all for coming. Massively appreciated. Please get in touch with questions. Please register. Please use it. Please, get involved. Thank you very much. Thank you, Pooja. Thank you, Anna. Thank you, Jo. Thank you all for coming. Thank you, everyone who developed this. Thank you a lot.
Great stuff. Thank you.
Thank you.
Bye.
Everyone. Bye.